Record. Hi everyone, welcome to the Edmonton R User Group's 2022 June meetup, when I'm going to talk about leaflet maps and raster dataset. I'm going to share my screen and begin with some housekeeping. So I've prepared a couple of slides for today, and I'm going to go into slideshow mode. Hopefully you can all see this bright orange as usual. So as a reminder, we are meeting last Thursday of every month. Somehow I figured that this is going to be the last Thursday. However, next Thursday is still June the 30th. So irrespective of this little mistake, this is going to be our last meetup for the year. And this R user group, as every other R user group, is where we come together as R enthusiasts, either people who already know R or thinking about learning R, to talk about all kinds of topics: data analysis, visualization, Shiny. So welcome everyone. Thanks for joining us today. As a reminder, Edmonton is located on Treaty 6 territory, a traditional gathering place for diverse indigenous peoples whose histories, languages, and cultures continue to influence our community. So thank you for the opportunity to live and code in R here at Treaty 6 territory. Our sponsors are the R Consortium, who are providing us with the meetup space, and Lithium, who is providing us with the conferencing. So today I'll talk about raster datasets and how to display them with the wonderful Leaflet library. And I don't know how many of you have heard about Leaflet, so maybe this is a time to do a little bit of roundtable just to see if you have worked with raster data or know Leaflet already, because there aren't a lot of us right here. I thought that if you can say a few words about yourself, where you're from, and something about, like, have you used raster or worked with Leaflet before? Thomas?
I can start if you want.
Sure.
Okay. Hi, everyone. My name is Ronnie. I'm from Costa Rica. I am living here in Edmonton. And I have used Leaflet, but not to display raster files in R. I have just used it to put it in some Shiny applications, and that's it. Not anything too complicated.
No problem. All right, who wants to go next? Someone in the chat. Not in a place where I can talk, but I've used Leaflet before for work, from St. Louis. This was Thomas Kaysen. Thank you. And we have Pete Jones.
Sure, I can go ahead. Hi, everyone. I'm a postdoc at U of A here in Edmonton. I guess I've worked with raster only in trying to do weird stuff with getting images into ggplot and that kind of stuff. And I've kind of been forced to learn a little bit about how that works, but I haven't worked with Leaflet specifically. So I'm looking forward to learning more about this.
Cool, thank you. Charles. It's all right. Sergio. All right, let me know if you want to speak up, or just feel free to interrupt me or put things in the chat. I'm not forcing this on anyone, but thanks for the introductions. And it looks like things that I'm going to share might be useful and even new to most of you. So I'm glad that this is going to be an informative session. And I'm going to be quite technical, so this is a little bit of a warning, but I'm trying to keep it really high level, but really concentrating on some learnings that happened during the past few months when I was really digging in and tried to work with lots of raster data, as you will see. So a few words about myself after you have introduced yourselves. My name is Peter Solymos. I'm an ecologist by training, but I spend most of my days sitting in front of a computer and writing R code. I'm a data scientist in my day job at eSource, where I'm working with utility data sets and vegetation-related outages and risk analytics. That's what I do. And I'm a founder of the Analytium Solutions, who is a sponsor of Edmonton R User Group. And I used to work at the U of A at the Alberta Biodiversity Monitoring Institute. And this is probably going to show today because these raster layers will have something to do with wildlife. So about today's talk, I'm going to start with some motivation, where this is all coming from, that I'm going to share with you. Then we'll do some coding, where you'll learn a bit more about raster data and how that looks and why that's useful. And then the Leaflet library and the Leaflet R package gets introduced. And then we are going to then work with how do we display these raster files in Leaflet, and what kind of options we have, what are the pros and cons, and how to weigh this when you need to deal with lots of raster files, which is going to pose some challenges, as you will see. So first of all, this project and all this intimate relationship with large and numerous raster files began as I was working with the team who initiated this Western Boreal initiative. So you can see the leads are from federal government and also from academia. So this is where the funding came from. And basically this project is about studying wildlife and how their habitats are going to change in the future under climate change and various land use changes that humans are posing to the landscape, so that once you have these understandings of how the landscape might change, how species like woodland caribou or different bird and tree species might respond to that, then you'll be able to have these discussions about what should we do, how we should best protect these landscapes and the species to benefit everyone. And there were really big indigenous involvement as well. So this is the Shiny app, and these raster results are all about communicating the results to managers and landowners so that they can better understand all the outcomes of this study, which is really technical, lots of raster files, and it is not really helpful to hand someone a 2 terabyte USB drive. Okay, here are the results. Please make sense of it. So this is where Shiny and Leaflet and all those raster files are coming in. And a little bit more about the scientific background of how things were processed. There are lots of input layers, which include fire database, climate layers, species distribution models, and then future climate. And then you have these modules all written in R as part of the SPADES framework, which stands for Spatial Discrete Event Simulator. So then in each cell, you are going to forecast how things are going to change depending on their surroundings, how maybe fire is going to reset forest, how that's going to grow, what type of forest is going to grow, what kind of disturbances you might see in the landscape. And then putting that together with climate and how the different species at risk or just species in general are going to react to that. And then as a function of those, what kind of patterns we see emerging and what kind of management actions we might be able to do based on these results. So this is all like a really huge framework, and this is a small subset of that, how we are going to turn these terabytes of data into interactive maps to help communicating these results. So this is where I'm going to just go quickly to this website and show you this work in progress app. You can see we have raster data displayed here. You can zoom in and see high and low values, and then you can also pick a different species, select climate influence scenario, and see how then the results might change. So if you want to compare these two things side by side, the Leaflet library is also very handy because it gives you this slider. So on the left-hand side, you can see no climate change scenario, whereas on the right-hand side, you can see how abundance might look like for other flycatcher, which is an early sorrel lover bird species, how the landscape might be different. Same thing here, you can zoom in. So these raster data might have to be served from somewhere, and then you have the Shiny app to display that. So this is pretty much the motivation behind all the raster data, technical details that I'm going to share, how to make this more efficient so that it loads fast, and then you can kind of play with it, and the kind of color scheme makes sense when I'm trying to compare things, so that the medium, like yellow here, 0.8, is 0.8 on the other side. And then you see these really high values under climate change when we are going to have more disturbance in the landscape that is going to benefit this species in particular. So after this little motivation, just a couple of more slides before I go into the live coding. We are going to talk about the Leaflet JavaScript library, which is used to display these various geospatial data sets, including rasters in interactive maps. And this is a very famous open source mapping library. And the author, who happens to be Ukrainian, so if you go to the Leaflet Packages website, it is going to tell you how to donate to help Ukraine in these times. So he was also working with Mapbox, so you can view Leaflet as an open source implementation of Mapbox as well. It's really powerful, lots of plugins, and luckily there's an R package which wraps this JavaScript library, and you can read all about that at RStudio's Leaflet website. So now if you want to follow along, you can go to this link, github.com/nlithium/leaflet examples on GitHub. And from that repo, you can just grab the code as a zip file, or if you are familiar with Git, then you can open the Git folder on your laptop, and we are going to work with this index.r file. So you can also just open it up in your browser and follow along if you don't have computer open, or you can finish this later. Here is what I have in VS Code. I have this file open, and now let's dive into raster data. And I saw that we have a couple of more people who joined us today. Welcome, everyone. So first of all, we have a TIFF file. And if I click on it, then I don't really see much. But let me go back to GitHub and see. If I click on this TIFF file, it is not showing it. So this is how my Mac is displaying this file. it's like an image, right? TIFF, that's a valid format besides PNG and GIF and JPEG and maybe BMP to begin with. So that's an image format, and images are not too different from raster data sets, as you are going to see. And really that's where they are coming from. So if you think back, I don't know if you were using Windows 3.1, but that's pretty much the PC. My first PC was running Windows 3.1. And at that time in the 90s, most of the files were BMPs, bitmaps. And that means for each pixel, you have a coordinate where that should be, which corner or in the middle. And then it is going to have 3 values, red, green, and blue. And so this is the image format that satellites have used, or maybe now they have multiple bands, but it's usually red, green, blue, and something else. And this is how they take pictures at various bandwidths, and then that is composited together to get kind of what we would see or a fake image. And this is why these TIFF and other formats are very similar to images. And most of the technological advances that we know for images apply to raster data as well. So you can kind of compress all that information into a TIFF file. So we have this TIFF here, which is an image, as you saw. It's a very similar looking image than what we saw in the Shiny app. It's an area of within the Northwest Territories, and it captures American robins, MRO, American robin distribution at the 1 kilometer scale. So I start R, and now I'm just going to load this library, which is called raster. And this used to be the go-to library for raster datasets. And I'm going to tell you why that is increasingly not the case anymore, but it is still maintained and is working really well. So to read a raster file, you just need to use this raster function and tell where the file lives. And now we have raster data. And that is still reading the values from the disk. And we can see the dimensions, how many pixels we have in X and Y dimension, how many values we have all together, and row and column and cell, which is interesting because this almost looks like a matrix. And we're going to come back to that. What is the resolution in the units of whatever the geographic coordinate system is dictating? This is in degrees. What is the extent? That is just 2 corners of the bounding box. What is the source, which file it is, and then min and max values. If you have more than 1 band, you're going to see those bands show up here. So you go from low abundance to high abundance for the robins. If you're more interested in the coordinate reference system, you can access that as well. This is how you get it in PROI4 representation or WKT. You can also quickly plot it to make sure that it looks as it should. And now you see low values, high values, and what that geographic pattern where you expect robins to be more abundant and where they're less abundant, plus let long. And why this is unprojected, so we have just let long, that's because of Leaflet. That's how Leaflet expects the data to be. So that's why we went that way. Now for raster data, if you want a different color palette, then you can define something else, plot it again. And now it's just going to be a different palette. See, all the same values, same patterns, but different colors. So this is how you quickly change the colors for raster data. We can also aggregate it up. So instead of 1 by 1 kilometer cells, we can tell raster aggregate each 10 by 10 block. I'm doing it right now so that we have a smaller object to work with. And now if I print out the info, now it says source is memory because we haven't saved this. So this all sits in memory. You can plot this one as well, and you'll see it's much coarser. And there are lots of other things that one can do with raster files. I'm not going to go into all those details because today's talk is not really about what you can do with raster files, but how we can, once we have a file, how we can display it in Leaflet. But before we go there, let's just peek into what the values are. And you see min, max, and a bunch of NAs. Now, what are these NAs? What is the missing value in this raster context? If I go back here, you can see that this is the bounding box. We have some margin around that. And everything that you see here, which is the background color, white here, those are the NAs. So the values are like this in rows and columns. And wherever you have just the background color showing through, that is where you have NA as the value of the raster. So this is the dimension. You can see now, because it's 10 kilometer scale, we only have like 170 and 138 pixels in the 2 dimensions. And the resolution is now 10 times what we've seen before. Now, let's create a matrix out of this value. So what I'm doing here, I create a matrix where I'm pulling out the values from this 10K raster object. I'm telling that the raster has number of rows as 170 and number of columns as 138. And then we can use the image function to create a heat map of this matrix, which is going to look like this. Not very nice. Something isn't quite right with this. So let me try different. So now we are reading it by row. Now it's much better, but somehow it's rotated and flipped. So we need to fix that. And you see that this is the corner, which should be up here. So to get everything right, you see we have to tweak the coordinates and also transpose the matrix. But eventually, we're going to get it right. So there's a particular way how the values are ordered in this matrix-like representation, which is not necessarily the same way as how you would view it in, for example, Excel or in a CSV file, but it's very close. So it is just an affine transformation that you need to make to get it right. And this is pretty much, I was just trying to demonstrate that really you're looking at a big matrix. You can also modify the values. So you cannot just only get those values, but you can override them. And now what I did is I multiplied all the values by -1, and I set the NAs to +1. So let's see what that does. Now we have something else. So 1 is going to be all where there used to be NAs, and now these are just scaled differently, and negative something means that's the largest abundance. So this is pretty meaningless as a map, but I just wanted to demonstrate this is how you can modify the values or do all kinds of arithmetics on that. So now, why do we need another package to deal with raster data? That is explained in one of these blog posts by the R Spatial folks, because there are big changes around various geospatial projects, including Gdal and Geos and their corresponding R packages. and also that Roger Byvand is going to retire, who was the maintainer of these packages. So there's a big shift in moving away from SP and using SF instead. And there are packages that depend on SP and raster, on what to expect there. And they are basically saying that although raster is going to work fine, probably in the future, but now the functionality is big move to another package maintained by the same author who wrote Raster, Robert Hijmans, and Terra is going to basically replace Raster, and it already has all those features and a couple more. So if you install the Terra package, you can read rasters the same way. You can print out information, which is going to be very similar, except the class is now spatial raster instead of what we had before. That was just raster layer. So it is a little bit more modern implementation, and some of the defaults are going to look a bit different, but not too much. So the color scheme is all the same, but now we have these little ticks along the color bar. All in all, this is still very similar. You can also create multiple layers as a list. And if I do that, then I have now the dimensions times 3. So not just one layer, but 3. Number of layers is 3. And if I plot it, then you're just going to get all those layers in their own little plot windows. And there are other metrics that you can get if you're just interested in the distribution of the values. You can plot a histogram or a very similar looking density plot, which is based on a subsample of all the values. And if you have more meaningful map than this, they can also create a perspective plot or create contours, which is going to look quite ugly for this high resolution image. But there are a couple of these basic plots that you can create easily. So this is just to set you up for future success. If you need to use Terra, your life is not going to be very different from what you did with the raster package. Now let's talk about Leaflet. Any questions so far about raster data?
No.
Okay. So then you need to install and load the Leaflet package, and then you'll have a Leaflet function. If you call the Leaflet function without any data and any other modifications, then you're just going to get a blank map. You can click on this plus minus, which is zoom in, zoom out, but you're not going to see anything because the first argument to this function is going to be the data itself. So I can bring the help up. You see leaflet data equals null. So we need to provide some data, or at least we need to tell what kind of tiles we want to show and where we want to center that map. So this is what we do next. So we're going to store this leaflet object in an object called M. So what we do here, we create this empty map, and then next line we just tell set the view so that it's centered around Edmonton, and set the zoom level to 12, which is we're going to zoom in, and then add tiles, which is just going to add the default OpenStreetMap tiles. So now we have this object. It has class leaflet and HTML widget. So HTML widget means that it wraps a JavaScript library. And if we plot it, so print it, the print method is going to open it up in the browser, and we can see this is Edmonton. Now we can zoom in more. And as I zoom in, you see more and more details, which is something I'm going to talk about in a second, what is happening there. But probably you already know the answer. What you see here, these are map tiles. And map tiles are like rasters. It is an image. In fact, you have lots of images depending on the zoom level. You have different details. And that's not because you really zoom out, but you are looking at a different image. So when you start zooming in, your browser is just going to replace the images with something else. And now you see all the footprints of the houses, Roja Palace, and so on. So there are a lot more details because you have higher resolution images with more details coming from a server. So these are map tiles. And this is what we added when we said add tiles. That's the OpenStreetMap, but there are other providers that you can specify. For example, you see OpenStreetMap and variations of that, and lots of others. For example, CartoDB. If you want to use CartoDB's positron base map, then it looks like this. So you can explore which openly available base map you want to use, which looks best with your data. There are lots of different options. Now, this is not really raster data, but we have this earthquake data set from the Pacific. And I'm just giving you a quick overview of what kind of markers you can put on a map. This is the default, just a pin with some pop-ups that you can close. And that's pretty much what you get if you just provide that long point data set. Now, how to color these markers? And by marker, I mean these little icons or pins that you put on a map, which can be a pin, a dot, a rectangle, whatever you define, even small images like cars or little human figures you can put up there. And how to color them, you need to pick a palette, which is either you're just telling is the Viridi scale, or you can have a sequence of hexadecimal color codes, which code red, green, blue, and possibly the transparency, although in Leaflet you specify opacity as a different argument. And then you specify the domain, which is either just a vector and it is going to look at the range, or you can specify it as two numbers, min and max. And so you're going to map the range of the color values to the range of the domain. And this is really important if you have, for example, subsetting the data and your min and max is changing. If you want to have a consistent color scale, then you need to set it up front in this function. And you can read all about that in the help page. Right now, we're just going to have all the quakes data, not just the top 20 rows. And we are going to have dots and this Viridi scale that is going to look like this. And just to demonstrate the power of Leaflet, with one little modification here that I'm saying cluster options equals marker cluster options, which is just the default thing, how you can clump together multiple data points. Now, instead of lots of points, you just have an overview. Here you have 7, here 55. As you zoom in, you see more and more details. And then you can specify when to start showing the individual dots. So this is something that you see a lot when you are viewing maps that have lots of details. And this is the kind of abstraction that Leaflet allows you to have. So this is really powerful, although we are going to focus on a really narrow subset. Now let's see how to add the raster data to Leaflet. We had this R object, which is just our usual Robin abundance map. Let me aggregate that again to the 10-kilometer scale. And now we can specify the palette as this magma, which is also from the Viridis package, but it's a more purplish colored palette. And then the domain is going to be the values from our raster object. And we also set any color to be transparent because we are going to have all those corners where we don't have any real values. We don't really want those to show up in the map. So now, once we specify this color scheme, we can say, this is the leaflet map. We add some base maps in the background with the add tiles function. And then we have this add raster image, which raster, and then the color function and what opacity to use, which is going to be the transparency or the alpha channel. Now, one thing that I haven't really explained is this pipe operator. You might be more familiar with the Magritte pipe. This is now the base R equivalent of that. And what that means is that the next line or the next command, its first argument is the map from the previous line. So that's why we are omitting that when we say add tiles or add raster image. But you can also write something like this, leaflet. Now M becomes add tiles M. And then M becomes add raster image MR, and so on. So this is another way how you can write this. But it's more commonplace to see this kind of pipe notation when we are working with leaflet maps. We got a warning because of the projection. And we also need to say print that map. So this is our Robin map now on an OpenStreetMap base layer. And if I zoom in, then I start seeing more and more details. And because we set the transparency, you can see the river showing up as well. Now, let's see what happens when I do just the original 1 kilometer resolution. It takes a bit longer, and that's why I was using the 10K at first. So it's now, as you can see, higher resolution. That's all fine. But it took some time to actually render this map. So what happens in the background when you say add raster image, it takes this raster, which is the big matrix, and now you create a PNG image with the color mapping that you defined as part of this color function and this opacity. And now you take that PNG image and put it on top of everything in the map. And that takes time because it's a higher resolution image that needs to be rendered. So this is a really easy way to just show a map in Leaflet, but sometimes we want things to work faster. So if, for example, in the Shiny app, I have these rasters on the disk or pulling them from some database or file system. Every time I add that to a map, it is going to take some time, especially if that is a big file or high resolution. So we are going to see some tricks how you can pre-process everything so that it loads faster and you won't need this time to really generate PNGs on the fly. One other important thing is now we add a legend. So now instead of just having the raster showing up, we have this legend as well. So this is how we add the legend. We take the map, and this add legend command is going to take its first argument as the map. That's why we have just a pipe there, palette, the domain, and what the legend title should be. Now, there's an interesting package called Tyler, which takes the raster and it creates not just one PNG image that you see here, but a whole set of them. So at every different resolution, you're going to see, like if I zoom really far out, now this image, it doesn't have to be really nice and high resolution. However, when I zoom in, then you want more and more details. So the same thing, what happens with this OpenStreetMap, if I keep zooming in, I'm going to see more details. Now I see that this is highway number 1, wetlands, and so on. So this Tyler package is going to do the same for our raster. It is going to create a tile system. If you want to install this on Mac or on Linux, there's going to be some steps to do because it relies on Gdal and Python. So you need to have all those installed. It's not impossible, but it takes a few steps. You can kind of use this as a guidance. I haven't tried installing this on Windows. It might be a little bit harder. So once I load the library and I define now another different color scheme, which is spectral from this HCL colors GeoDevices function, that's quite common in raster environments to use this spectral color scheme. The main function in this Tyler package is called tile. So you take this file and generate tiles from various zoom levels, 0 to 7, so that it completes fast enough, and what palette to use. Now let me see if I can run this, and also here is my file browser. So you're going to see some directories and files popping up there. Reprojecting raster, which is really not necessary. Generating base tiles. And then overview tiles. So the base tiles are the ones which are at the finest, like zoom level 7 at this resolution. And the overview tiles are, you can think of them as parts of a pyramid. As you zoom out, you see less and less details. So now we have an HTML file plus a directory. At each zoom level, you have maybe just one file, which only shows like this tiny little speckle here, which is the whole study area. Now zoom level 1, you zoom in a bit more. Let's see, zoom level 5. Now we have 3, 4, 5, 6, and then all kinds of PNGs showing parts of the same image. Now you see this is not empty. Now you have kind of some corners showing up here. This is like a puzzle. You have all these pieces. So why we do this is that the overview is just going to load whatever is in the view. So that way you don't have to load everything all at once. When the user is zooming in, you can just refresh that part, what is in the view. And this is that kind of efficiency that you can get from this tile system, which is very similar to what you see in the background here for OpenStreetMap or Google Map or anything else that you use on your phone or in the browser. So there are a couple of links here about where you can kind of find more information about tile map service either the specification or just nice little images that you can use to kind of see what is really happening here. So this is how you get the different tiles split up. And this is that kind of coordinate system that you see here as part of the directory structure, like right here. Within the zoom levels, you have one coordinate that is another directory, and the other coordinate is going to be just the file name. So there are two types of systems. One is called XYZ or ZXY. And then sometimes you have to flip the Y coordinate as a minus. And this is how you specify the path. So if you have these files sitting on a server somewhere, which is quite common, and that's why it is called map-tie service, because really this is a file system somewhere on an HTTP server, so you can make GET requests and read the files. So this is the URL for the Western Boreal project. We have an API exposing these files, and then we have a directory structure. Within the directory structure, we have a folder called tiles, and within that, now we have this interpolation curly braces. So this is going to get replaced by the Z coordinate, which is the zoom level, X, which is the next folder, and then minus X, so -1 times this number. Plus, you also have this XML file detailing a couple of other things that the display needs to know. So this is how you put all that together. So if you define these tiles, and now in Leaflet, instead of accessing the raster file as we did before, we can just provide this add tile function and use a URL template that we defined in this string called tiles. And then we can specify other options, like what native max zoom level, so that you can still zoom in after that, but you're going to see an interpolated version, opacity, and then Z index. And the Z index makes sure that the base map that you see in the background is always going to be in the background. So this raster is now going to be on top of that. So 400 is higher than 200, which is the default. And this is how you can order the layers if it's important to have certain layers always on top. So let's see what happens if I do this. Now we have this nice Google Esri Earth image in the background. And then as we zoom in, we see more and more details because we just have these tiles loading. So you're now reading all those PNG files from a remote server. And this is how you can host your tiled raster images. Now, let's say we had this nice spectral color palette. What happens if I want to change that? I can't really do that because these PNGs are already pre-calculated. So if I want a different color scheme, then maybe I need to add another level in this file structure. Maybe before tiles, we would have spectral/tiles ZX-Y or viridis. So if you want multiple options, you need to run the tile processing multiple times with all those new color schemes, which can be pretty daunting. And then you're just basically taking up more space on the server, which might not be optimal. So instead of that, we already have this GeoTIFF image, and Leaflet can display these GeoTIFF images instead of the tiles. So here I have another version deployed just to GitHub pages, so we can test another mock API. we have in the leafem package, leafem, a function that helps us with adding the GeoTIFF version, because it's not part of the base Leaflet library. There are a couple of plugins that leafem implements as part of the whole HTML widget thing. So you can do something like this. Add a GeoTIFF file directly and specify some color options, and this is the color mapping to the domain and what to do with the transparencies. Let's see what happens here. And this brings up one of the issues that we run into while we were working on this project. And let me just close a couple of these tabs. So now this is what we are looking at. This color for the transparency is not really what we are looking for. This is a transparent black, and it took some time to figure out what is happening. And there's a whole issue describing what we tried and why this is happening. So you can go there in our spatial and see what the discussion were about. But all in all, there was a difference between how raster represented minus infinity, which is a placeholder for missing data in the TIFF version, whereas what the JavaScript library was expecting. So this was just a floating point issue, like 10 to the 38th versus 37th kind of difference, like really, really tiny difference, but therefore it is showing up as black. So if you want to avoid this, then you need to use another package again, which is called stars. And stars is not really just for raster datasets, but it's also just all kinds of spatial temporal arrays. So it extends the concept of a raster to all kinds of datasets, but it can also write rasters without this floating point issue. So if you load the package, then you can turn your raster into a stars object, which now we are going to call S. You can check what it looks like. You can have another implementation of this plot. Now it's black and white. And this is how you would write it. Write stars, this S object into, well, this is supposed to be the file name. Something like this. And then you can also specify options, what compression to use, because otherwise it's going to be uncompressed, which is pretty big. So this 1K resolution file is about 2 megabytes. If you don't use compression, it is like 10 times that much. So now if we use this updated image, which I already uploaded to GitHub pages, then you can see now the transparency is all right. So this is a little trick. If you want to serve GeoTIFF files that has some issues with transparency, then maybe check out the stars library and save it that way. Now, just to see how you can modify the colors on the fly, here's a little app that I put together where you can change viridis, red, yellow, blue, the spectral that we used before, and then this other scheme, which is this yellow, green, blue thing. And so I put this together because you can change the base map, and depending on what's in the background, some of these colors are going to be really washed out. So you can play around and inspect what looks nice over various base maps. And so I sent it out to some users, and then they were able to provide some feedback on their preferences. And at the end, we just settled on the spectral because that's more colorblind friendly, plus looks good on all kinds of base maps. And if you are interested in how this little shiny app was put together, in the same folder, you can open up the palettes.r file, which is going to load some packages, define a few functions, and then have this very simple shiny app with a UI just showing a side panel with this slider and then a leaflet output. And then in the server function, it is really just the map that you see here. So you can go and see how this is put together and maybe use it for your own purposes. So let me stop here for a few minutes and maybe ask you if you have any questions, or maybe have a brief discussions about pros and cons of these tile service versus GeoTIFF, and how to best serve raster data. Any ideas? Any questions? All right. So I can tell you some of the thinking that went into deciding what to do for this app in particular, but also that might not be the same as what we are going to do maybe next time when we go for a larger extent or have more files or bigger files, because it's quite tedious what we did. We just created lots of PNG images because we created the tile service, but because it is already pre-processed, you can't really change the color scheme. And also it might be a challenge to keep it up to date if there are changes to the underlying data. So this is where GeoTIFF comes in, which is not too huge. It is just one file, and Leaflet can display it no problem. You can have the color changed on the fly. So it might be actually better, but it takes a bit of time to load big TIFF files as compared to small PNGs. So we went for speed at this time, but there are other ways, and there is something called cloud optimized GeoTIFF, which is really just have best of both worlds, because it can have an overview as part of the file, which is going to bring in those pyramids. So you can read in a coarser resolution things before the whole file arrives. And another difference is with this cloud optimized TIFF, you can also just read in smaller subsets of the whole raster, because it is not stored as a big matrix, but is stored as a series of smaller matrices. Currently, you can't write cloud optimized GeoTIFF in R, and you can know that from the SF drivers. If you list the drivers for raster data, then here's a line for cloud optimized GeoTIFF, and it says you can currently write these types of files. You can copy, you can read, but you cannot write. But if you have Gdal installed on your computer, which is something you need for the tile package anyways, so if you are on Mac, on Linux, then you can install that based on the code I showed above. And now you have a couple of lines that you can run. So let me try doing this. I read in the raster file. I turn it into a stars object just to make sure that the NAs are correct. And now I'm going to save it into mrow1k over, because we are going to add an overview eventually with some compression. So now I have this TIFF file. The next thing in another terminal, I'm just going to use this Gdal add O, which creates the overviews. So it averages the values at 2, 4, 8, 16 aggregation levels. This is what we saw for the Tyler package. So this is how it creates the overviews. And then the next thing we need to do is this Gdal Translate. That's another command line argument for Gdal. And we use this as the input file. The output is going to be mrow1k-cog. Compress the file and use it as like tiled, which is going to have those subsets saved instead of the whole thing as just one block. So now we have the cloud optimized GeoTIFF. So you can write this file outside of R currently, but hopefully things are going to improve in the future and you'll have this natively in SF or stars. Now, going back to Leaflet, in the leafem package, there's an experimental add cog file that I couldn't quite figure out how to make it work with my cog file. So there's an issue about this as well, why it's still not working and what we can expect in the future. But if I just throw in this cog file, which I already uploaded to GitHub pages, and just add it as a GeoTIFF, something really interesting is going to happen. So let me open it up again, and I'm in the wrong console. So this is a high zoom level, but as I zoom out, you see the overview tiles loading. So this is already somewhat different from the previous GeoTIFFs because at least we have the overview. The whole point of the tiled version of the GeoTIFF is that if it's sitting on a server, the GET request can specify a range of bytes that is going to read instead of the whole file. And that's the advantage you get with these cloud optimized TIFFs, that you're only going to read parts of the file that are in the active view. So this is the kind of optimization that is going to arrive to R at some point when this experimental leafem function is going to be finished. In the meantime, there's a JavaScript plugin that can display cog files. Any questions so far? So this was my hands-on part of the presentation, and I only have some summary slides left. So let me then review those quickly. We talked about raster dataset in general, that those are just big matrices or arrays if you have multiple bands, and there are quite a few R packages that you can use to deal with the raster files, including the raster, terra, and stars packages. Now, when it comes to adding these to a leaflet map, then you can just use your local file, which gets turned into a PNG and displayed that way, or you can do this pre-processing yourself upfront using a tile map service or directly serving GeoTIFFs using the leafem package. And you can also then have overviews as part of your GeoTIFFs or save them as cloud optimized TIFFs as well. Now, why these choices are important? Because how quickly a big raster file loads, it can impact the user experience. And depending on whether you need to serve or host thousands of little files, like PNGs in this TIE system, versus a single GeoTIFF, that is going to impact the maintainability of your code or your file system on the server. And it might also impact your hosting costs, because you might have multiple versions if you want different color schemes and so on. So these decisions of which format to use when you want to display a large number of raster files over a web application is going to have some of these impacts that you need to think about. And hopefully my talk today is going to help guide you in that decision. Are there any questions or other points that you'd like to discuss? Well, if not, then I have a couple of more slides. And I just wanted to mention that our next Edmonton R User Group meetup is going to be at the end of September. And I just now going to review what we did in the past 10 months. We have grown quite a bit, starting from 0. Now we have more than 200 members who are receiving notifications and showing up time to time, or just watching the videos after the meeting. We had a really good lineup of presenters, starting in December with R in production, then open science with Steffi Lazarte, and then model fitting, ggplot, ArcGIS integration, a joint meeting with the Calgary R User Group, parallelizing your code, interactive visualization with the eCharts JavaScript library, then a one-day workshop about how to write our packages, and then Ronnie talking about scientific and technical communication through websites that you can build from R, and today's talk about Leaflet. So this was a really good lineup, and we are going to continue this the next year. We are thinking about trying a few of these meetings in person, and we'll see where we can find locations. If you have suggestions or ideas or know someone who might be able to host this, please let us know, get in touch with us. In the past, we used to have meetings mostly at the U of A, and I know Startup Edmonton has limited places downtown. I don't know now that things are returning after COVID, how things are, how crowded they are, or whether people really need to have a convenient place anymore. If most of the folks are working from home, then maybe that's the only drive you are going to do in the whole week, to go somewhere for an R user group. We'll see how that plays out. And we can also keep things hybrid so that people can remotely join us, or if we have a presenter who cannot travel, then they can still present, whereas we come together in person. So with live streaming and recording these meetings, we can still keep the hybrid format, even if we go back to partially in person. And this brings us to the topics. If you have topics that you are really interested in learning about, let us know. We can find someone who might be able to talk about those. Or if you yourself have something interesting to show and tell, then please consider letting us know that you'd like to present something. It can be really small. We are all here to learn. And if it helps some people that we go through some even really basic stuff, that is also something that is really welcome. Just have some more foundational understanding of data structures or plots or another ggplot seminar, those are all welcome. So whatever you learn today, you can teach someone tomorrow. That's how I think about it. So please don't be shy. We are looking for speakers so that next year is going to be really awesome as well. And if you grab this QR code, or I'm going to put this link in the chat in a second and probably send out to the whole user group on Meetup. This is where you can go and provide some feedback about what kind of workshops you might be interested in. And by workshop, I mean meetings outside of the regular meetups. I might even have this open here. So here's the link in the chat. And if you go there, you're going to see you can kind of rate all these topics that I could think of that we could potentially have a workshop around, just general R introduction, some basic statistical analysis, visualization with ggplot, more about the tidyverse, spatial data sets, Prolog programming, Shiny applications, publishing with knitr or markdown and so on, or learning about Docker containers, how you can move your code from your local environment, or anything else that might be on your mind. So please spend some time giving some feedback and ideas about potential topics, and then we'll do our best to make that happen next year. We still have quite a bit of time till 8, but I'm not going to keep you here. Just if you have something to say, now is the time. We can still have a bit of a chat